Hello, my name is John Maxwell and I'm 11 years old in the 6th grade. I have been living near the Hudson River for over 4 years now and have been learning about the river's history, biology, evolution, and great beauty. The river is a very special place and we should do everything we can to preserve and take care of it. This magnificent river was first discovered by Henry Hudson and his crew in 1609 aboard the Half Moon ship. Today, I'm going to discuss the Hudson River and the living creatures that live beneath the surface of the water. I will also take a look at the fish population, salt levels, pollution and human impacts, and sea levels of the river. There are just a couple things that I want to make sure you know before we get started. First, the river doesn't flow just one way. It flows both north and south ways, with the fresh water and salt water flowing together. This is what's called an estuary. An estuary is where fresh water from the land meets salt water from the sea, and they're both governed by the tide. The water doesn't flow just one way, it flows both ways. In fact, the Indian name for this river a long time ago was called Mehiakantuk, which means the river that flows both ways. Estuaries are among the most productive ecosystems in the world for one very simple reason. The river gets its energy from the marsh plants, from the underwater vegetation, from the sun, and from the leaf fall in autumn. But instead of being flushed out to sea, the salt water coming in and the tides coming in and the fresh water pushing it down, it's basically held in place. The Hudson Estuary is created by fresh water flowing south from the Adirondacks, colliding daily with the salt water flowing upriver from the Atlantic Ocean. Also feeding its flow are countless tributaries, or little streams, entering the river from a territory of over 14,000 square miles from 5 different states. What's found in these streams are not lost when they get into the Hudson system because the tides keep it in place. If the stream went into a river that was a classic river and only went one way, it wouldn't be as rich. It's a supermarket that never closes and it's free for the taking of the animals that are there. Now that you know these key points, we can start looking at the data. First, we can dive into the fish population. The fish population represents the number of fish in the river. In this case, 8 different fish in 6 different locations. The people monitoring the fish did the recordings over a course of 10 years, from 2004 to 2013. The fish they monitored were 8 types of fish varying in fish salinity levels, which is the amount of salt a type of fish can endure. Some fish may prefer the fresh water at the northern part of the river, while other fish may prefer a saltier habitat closer to the ocean. The fish are Atlantic silverside, a small species of fish from the West Atlantic; blue crab, a species of crab native to the waters of the Western Atlantic; Ctenophora, a phylum animal that lives in underwater waters worldwide; striped bass, a large striped Atlantic fish; banded killfish, a freshwater North American species of Fundulidae; pumpkin seed, a freshwater fish of the sunfish family; spot-tail shiner, a small medium-sized freshwater minnow that lives in lakes, rivers, and creeks; and sunfish, the cousin of the pumpkin seed. I have drawn many graphs for the fish population. However, there are lots of variables that could throw off our immediate results. Because of this, I am going to talk about the salt levels, pollution and human impacts, and sea levels first, and then compare the fish populations to the results of that data. So let's do that now. Salt levels represents the salt content in the river. They tested the salinity in the same 6 locations as they did the fish, so this will be very easy to compare for the fish. They did this every October for 10 years. We will use this time span to see if this is one of the effects on the fish population. I will now show you the graphs for each town. Here are the 6 towns they recorded the salt on. Now let's keep in mind that the closer the river gets to the sea, the saltier the river will get. So the salt level should get lower and lower as the towns get higher and higher. So let's start with the southernmost town, Bexac. The amount of salt is measured in parts per million. Seawater from the ocean generally has a salinity level of about 35,000 parts per million. Fresh water draining into the Hudson River usually has a salinity level of about 25 to 50 parts per million. On the Hudson River, scientists consider salinity readings of 100 parts per million or higher as an indicator of the presence of seawater. In other words, as salt water enters the Hudson River, the edge of the salt water will be 100 parts per million or greater. We can use this to read the graph. Starting at 2004, we can see a not so large level at only 2100 parts per million. It was a warm, sunny day. We can see that the levels made a small climb in 2005 and 2006. 2005 was disturbed by Hurricane Tammy, and 2006 was just a little sprinkles. And then we see a big change in 2007 as the salt goes up to over 15,000 parts per million. Take note that it was after a very dry year. Then in 2008, it decreases down to only 6,000 parts per million. It was a crisp, clear day with minor winds. In 2009, it slightly goes up 500 parts per million on a very strong wind day and night. It blew a lot of fish around, that's for sure. The levels were about the same in 2008 and 9. In 2010, it decreases even more on a foggy day. 2011 was also pretty low. We shouldn't be surprised that it was because of Hurricane Irene, which was pushed down by all of the rain. 2012 increases by 8,000 parts per million. Again, this came after a very dry summer. It was a rainy, misty day. And lastly, 2013 stays the same as 2012 and was a cold day. Few of the Atlantic silversides of fish in Bexac were netted, many effects from previous Hurricane Sandy. One trend that we notice here is that the salt levels are above average after dry periods. So that's it for the salt levels at Bexac. The next town up is Piermont. This trend of data at Piermont kind of resembles the data trend at Bexac, just lower numbers. In 2004, it's low on a sunny day. In 2005, Piermont received almost 4 inches of rainfall on the day, added to the hurricane impact, making a little more than what it would be if it were relevant to the Bexac data. In 2006, it continues the small climb from the little sprinkles. In 2007, it dramatically changes with the cause of the dry weather. In 2008, it decreases with the crispy small wind day. 2009, it pretty much stays the same with the very strong winds. 2010, it goes down with the thaw. In 2011, the heavy rain from Hurricane Irene swelled up the river, which decreases the salt a little more. In 2012, it increases again with the heavy mist and rain during the day. This is also after a dry period. And in 2013, a fish common in Piermont, the Atlantic silverside, didn't have a great catch on a cold day following Hurricane Sandy. Next is Beacon. This town is a little away from the sea. This means that the water isn't as salty here. Because of that, we can see that there is hardly anything on the graph in large numbers. So let's just say that this town's data is low. The last 3 towns, Norrie Point, Ulster Landing, and Green Island, are very far from the sea. And as we can see, there is hardly anything on the graphs of all 3 of these towns. So let's just say that there are some trends that we notice. The salt is highest after dry periods, and hurricanes don't really have a straight impact on the salt. It can vary. It depends on where the hurricane is going.